just so we can get in a little bit of stuff before, oh, here she is. Welcome, welcome. All right, so we're going to go ahead with lecture and we'll figure out how to get everybody to see the class t-shirt at the same time. So we talked about modes of ventilation last week. We went through a couple volume modes and then we got into pressure modes. We went through pressure control. We talked about PRVC. And now we're going to talk about spontaneous breathing. Where did it go? Nope, that's not it. How can it just disappear off the face of the earth? All right, I'll download it again because I don't see it. Well, this one has a voice. Thank you. All right. So we got the recording on, we're on the right PowerPoint slide. So we're talking about a spontaneous mode of ventilation. And this is where we don't set a rate on the ventilator. We let the student just breathe spontaneously. So while they're breathing spontaneously, we want to help them with their work of breathing. So we always add pressure support to spontaneous breaths. And we always have some PEEP so that we prevent atelectasis while they're on the ventilator. So you'll always have pressure support, you'll always have PEEP. So when you're in this mode of ventilation, CPAP mode with pressure support, and you're asked to classify the breath, it's not a mandated breath, it's a spontaneous breath, you would be classifying what pressure support is. And pressure support is a pressure limited flow cycled breath. So if you set 10 centimeters of water as your amount of pressure support, then when the patient initiates a breath, they're going to get some positive pressure blowing the air into their lungs, like 10 centimeters of positive pressure. And that's going to help their work of breathing. It's going to make their tidal volume a little bit bigger. So the ventilator needs to know when the patient is done breathing in and they're getting ready to exhale. And the way that the ventilator knows that is it keeps track of how much air is flowing into the patient's lungs. And it notices that as the flow is slowing down or diminishing, that inspiration is getting ready to end. So it keeps track of the amount of flow going into the lungs. And when the flow diminishes, that means that inspiration is ending. So when we say pressure support breath is flow cycled, it means that when flow diminishes, inspiration will end. So flow cycled means that when flow slows down, inspiration will end. When inspiratory flow slows down, inspiration is getting ready to end. So when you turn on the ventilator and you're setting the patient up in pressure support with CPAP, one of your settings, it's called different things on different ventilators. You'll be using the servos mostly, and it's inspiratory cycle off percentage. And am I telling you all this and it's already written down? No. Okay. So when you turn it on and you see your inspiratory cycle off percentage, it defaults to typically 20%. So the inspiratory cycle off set at 20%. What does that mean? So as the ventilator is keeping track of the flow going into the lungs, the initial flow is considered 100% of flow. And as the flow slows down, it's percentages of initial flow. It is the percentage of the initial flow. So when the flow slows down to, let's say, 20% of initial flow, then inspiration ends, and the patient is able to exhale. What does the ventilator do to make inspiration end and exhalation begin? Do you guys know? Opens. Yes, very good. So what the ventilator does to get exhalation to start is it opens up the exhalation port. And now air leaves the circuit, it leaves the patient's lungs. So hopefully that helps you. I know we all struggle with trying to explain what inspiratory cycle off is, let alone trying to figure out when to adjust it. So you'll notice when you're with other respiratory therapists, the default always stays. You never see them change the inspiratory cycle off. So the question is, why would you want to change it? If it's set to 20%, why would you ever want to change your inspiratory cycle off to something else? Do you know the answer to this already? What's that? I didn't hear that. You're thinking of the rise to pressure? Yeah, air hungry patients like a fast rise to pressure for your pressure control and PRVC. But this is a spontaneous breath that's getting ready to end. So the reason that a pressure support breath doesn't end is when flow doesn't diminish. Why doesn't flow diminish? It's typically because there's a leak somewhere. As air is going out the leak, the ventilator thinks the patient's still breathing in and flow is not diminishing. So with a leak, you're going to see pressure support breaths, and you're going to see these really long inspirations on your graphics. 2, 3, 4 seconds, really long inspirations. And you think, wow, that patient's breathing in for a long time. Well, they're probably not. They probably have a leak either around their cuff, somewhere in the circuit, and that leak will have a continuous flow of air, and the ventilator interprets that as them still breathing in. So why would you adjust the inspiratory cycle off? You would adjust it if you see a long inspiration with pressure support breaths. All right, so I'll put that in the chat. So why would flow not diminish? Because there is a leak somewhere and flow is going out the leak. So you will notice a long I time with a pressure support breath. So if you see this really long eye time, you're going to think in your mind, oh, I know what to do. Let me increase the percentage for inspiratory cycle off. So I wrote down, you will notice a long eye time with a pressure support breath. That is your clue to increase the percentage for inspiratory cycle off. I mean, you try to find the leak first, right? That's the obvious thing. Try to find the leak, fix the leak. But if there's still a leak, you're going to increase, instead of leaving it at 20%, what would you do? To like 30%, see how that works? Maybe 40%. Yeah, so you're going to increase that setting, and that kind of forces inspiration to end a little bit sooner. So, all right, doing this will force inspiration to end. So a higher percent cycle off will kind of force inspiration to end. So the biggest group of patients that you do this with is somebody who's got a chest tube in and there's air going out the chest tube. That's going to make pressure support have difficulty ending. If you have a patient intubated with a cuffless tube, like infants, pediatrics, you'll see them have this really long inspirations for pressure support. And it's again, because of the leak. So you fix that by increasing your percent. And then there's one other group, it's COPD patients. Their inspiratory flows are low as their real stretchy lungs are filling up. They don't have a lot of flow as the air is going into their lungs. So it doesn't really diminish down to 20%. So what I want you to remember is that patients with COPD might need a higher percent cycle off. So we'll just skip to the bottom line here. Patients who have COPD, they're on the ventilator, they will need a higher percent cycle off. Yeah. So the higher percent cycle off just makes inspiration end quicker. What is an inspiratory time that you think would be normal? Yes, say it louder. 1 second, yes, very good. So if it's 3 seconds and that's a flag to you, right? You see that these really long inspiratory times, is that going to be a flag? Hey, let me change my inspiratory cycle off percent. You got that connection between the two? Okay. What settings are indicated for pressure support? PEEP, FiO2, inspiratory cycle off,
CPAP.
this amount of CPAP or PEEP, yes, very good. And pressure support. So physicians don't know about inspiratory cycle off, so you probably won't get an order for that. They typically just order the amount of CPAP, the amount of pressure support, and that's it. FiO2 and so let me write it in. So the amount of pressure support, FiO2 and PEEP. And when you're in a spontaneous mode, PEEP is called CPAP. When you're breathing spontaneously, it's called CPAP. All right, so that's it for CPAP with pressure support. Now we're talking about airway pressure release ventilation. On the servo ventilators, it's called bivent. Other ventilators, it's called airway pressure release ventilation. Bi-level is another name. And then the abbreviation APRV seems to stick. So even though you're dealing with the servos at Broward, the servos at Memorial, everybody says APRV. But when you go to the ventilator and you look at your menu of all your different modes, you're not going to find APRV. You're going to find bivent. Have you had any patients on bivent in your experiences in the ICU? No? What about my friends on Zoom? Anybody experience bivent?
No, I haven't seen it yet.
Oh, okay. What was happening with the patient when you saw them recommend it? Do you remember? Yeah. So that's typically when APRV is recommended and how it works. So if a patient is on conventional ventilation or conventional modes like PRVC, pressure control, they're on a high FiO2, high PEEP, and they're still not oxygenating. What can you do? So by switching over to bivent and having these really long I times, like it ends up being around 4 seconds for inspiration. That long inspiration allows alveoli to pop open. And then there's a really short exhalation, and there isn't enough time for the lungs to completely empty. So you got a lot of air trapped in the lungs. And it's kind of a good thing for this mode. We want that air to stay trapped because all of that trapped air is going to keep the alveoli open. It's kind of like the auto PEEP will keep the alveoli open. So that's why you have really short expiratory times. Let some air out and then boom, inflate the lungs again. All right, so that's me explaining it. Now, what does the slide say? So with bivent, you're providing 2 levels of CPAP. And while you're providing these 2 levels, the patient can breathe spontaneously the entire time. Matter of fact, spontaneous breathing is encouraged because with this mode of ventilation, you don't have much of a minute volume and CO2s tend to climb. But if you allow them to breathe their spontaneous breath while all this is going on, it helps to blow off CO2. Add pressure support for spontaneous breaths. I know at Broward, they stopped adding pressure support for spontaneous breaths because if you have an inspiratory pressure of 30 centimeters of water, and then during that time, the patient takes a spontaneous breath, their pressures will be higher than 30 centimeters of water. And now you've got some barotrauma going on. So they stopped using pressure support and the patient just breathes a spontaneous breath. You guys know it's possible to breathe a spontaneous breath without pressure support, right? Okay. All right, so you have the lungs inflated and then periodically the pressure is released down to the lower set level for about 0.2 to 1.5 seconds and then back up to pressure again. This shows the drop-down menu for bivent on the servo. So there's 4 values that you're setting. You're set, well, other than FiO2. You're setting the amount of pressure during that high CPAP level. you're setting the amount of time to keep that pressure. So the way that it's dialed in on what we're looking at, for 4.7 seconds, there will be a pressure of 28 centimeters of water in the patient's lungs. And then after 4.7 seconds, the exhalation valve opens, the air comes out. Does the pressure ever get down to zero? And the answer is no. Because you're only there for 0.3 seconds, and there's not enough time for the lungs and the pressure to get all the way down to zero. So having a PEEP at zero doesn't really mean anything because the pressure never gets down that far. So those are the 4 settings. Pressure high, time at high, pressure low, time at low. So in this setting, will the patient have any pressure support with their spontaneous breaths? No, very good. It says pressure support is 0. Okay, so what it's pointing out now is it says the respiratory rate is 12 breaths per minute. And that's not a setting. That's the result of having 4.7 seconds of inspiration and 0.3 seconds of exhalation. Look at the IE ratio. Is that crazy? The inspiratory time is 15.7 times longer than exhalation. Is that the highest IE ratio you've ever seen? And then when you look on your airway graphics, you see your long inspiratory time, and that's your pressure high. You see the pressure released for a brief amount of time. That's why this is so short, or so narrow, I should say. Because the pressure is released for a little bit, and then it's back up to the high pressure again. So volume goes in, little volume comes out, and then inspiration occurs again. Oh, it's showing the air trapping occurring? How the flow is not coming back to baseline? And it's showing the exhale tidal volume. So some air comes out, just not a lot. When the patient is having a hard time oxygenating, so you have them on high FiO2 and high PEEP, and still their O2 stats are like less than 88%. And then this is just the ups and downs with the pressure, are just showing a little pressure support with the spontaneous breaths. So you can have spontaneous breaths on top of those 2 pressures that you're setting. It's better not to give a paralytic, but it is uncomfortable for the patient, so they do end up sedating them. But hopefully it's not something that suppresses their breathing, because you want them to breathe to blow off more CO2. And that's not comfortable, right? Oh, that's what you're thinking of. With that mode of ventilation, it wasn't too popular because you had to really heavily sedate the patient, give them a muscle paralytic. That's what you're remembering. Yeah. Oh, it's showing the spontaneous volumes. Okay, indications, improve oxygenation in severely hypoxemic patients. And then it gives you a list of what the physician needs to order. Does it explain? No. Okay. So your typical starting parameters when you go into Bivent. I'll give you the defaults or what they start with at Broward, because they use the mode a lot at Broward. The upper pressure is typically 30 centimeters of water. The time at upper pressure is 2 seconds. The low pressure, they put at 0, since the pressure never gets down to 0. So they just leave the pressure at 0. And the time at lower pressure, 0.5 seconds. Okay, did you get all those numbers? Do you need anything repeated? Did my Zoomers get the settings?
Yes.
Yeah, I got them.
Okay. All right, so now that those are the starting settings, let's say you get a blood gas and the CO2 is high on those settings. What could you do to get rid of more CO2? Oh, it does have it coming up.
Professor, would you lower the time for the upper pressure?
Yes, very good. And how does that help CO2?
It lowers wouldn't that like decrease the time they're inhaling and help them blow off more CO2?
Yes, very good. So there, it'll release or go to exhalation more often, and that interprets as a faster respiratory rate. So instead of a 2-second time at high, if you go to 1.5 seconds time at high, now you're going to be exhaling more often. So you'll see your minute volume increase. Very good. And then another way of getting rid of carbon dioxide is by using more pressure. Remember, the more pressure you use, the bigger your tidal volume. So you could increase the amount of pressure at high. You could increase the amount of pressure support. Not that it's favored by anybody, but it could be a way of getting rid of CO2. Let me check to see if it shows up. Is it coming up in the future? Yeah, it's written here. All right, so we wrote you would have more frequent exhalations or shorter I time. And then we talked about using more pressure. Okay. How is oxygenation managed? Increasing FiO2, that's the obvious one. And then the second way to improve oxygenation is to cause more air trapping. And the way to cause more air trapping is a shorter time for exhalation. So if you had it, what did we say for the default? So instead of 1/2 second for exhalation, if you change that to 0.3 seconds for exhalation, you're going to trap more air. And the more air you trap, the more you keep the alveoli expanded and your oxygenation improves. So how did you write that in your words? Yes, perfect. So improve oxygenation by increasing FiO2. Also by decreasing the time at low pressure. So that explains what you do, but do you have an understanding in your mind about if you decrease time at low pressure, how does that improve oxygenation? If you have less time to exhale, why does that help oxygenation? Yes. So the missing key is that you're causing more air trapping to occur. Okay, and then we'll go through the scenarios. You are caring for a patient in ARDS who is having difficulty oxygenating. Sedation is lightened to encourage spontaneous breathing, and the patient is switched to bivent mode with the following settings. The upper pressure, and it recommends starting with the plateau pressure from the previous mode that you were on. Typically 20 to 25 centimeters of water. I gave you 30. So you can use either number on the exam and I'm good with it. So if you use 20 to 25 or what Broward Health uses, they use 30 centimeters of water. That's good also. The time at upper pressure, 5 seconds. Or on the exam, if you want to give me the time that Broward Health uses, which is 2 seconds, that's okay too. Lower pressure, 0 to 2 centimeters of water. That part's the same. And then the release time at lower pressure. What does Broward Health use? 0.5 seconds. All right, so that's smack in the middle of this. So the first two are a little different than what's listed here. You can quote either what Broward Health does or these numbers that are on the slide. And then when you're switching over to bivent, you start with an FiO2 100%, and then you wean to keep stats around 90%. So you started with those settings. I need some water. So tell me about that blood gas. Tidjin, what do you think? Okay. So yeah, you always mention, you start with the pH and then go from there. So you have an acidosis, you have a respiratory acidosis, and then you mention the oxygenation. So your moderate hypoxemia. What changes would you recommend? And then it kind of gives you the answer, doesn't it? So to increase ventilation and get rid of some more CO2, you could increase the upper pressure. That's going to give a bigger breath, more volume. Here's one I didn't mention, decrease the time, oh no, we did. Decrease the time at upper pressure and allow more frequent exhalations. Yeah, we have that one on our list. And then the third one, increase pressure support on the spontaneous breaths. So that's going to give a bigger tidal volume. And anytime we have a bigger tidal volume, we exhale more CO2. And then to increase oxygenation, we cause more air trapping. And the way to do that, decrease time at low. Good job. All right. Are you guys okay? You want to take a break? You have to go through a few more modes yet. Yeah, so you want to take a quick walk around? Okay, we'll continue with lecture. The next mode of ventilation we're discussing started with servo ventilators, so they kind of have the rights to the name, volume support. So volume support is a pressure support mode. And the difference between pressure support and volume support is that in this mode, the pressure support is not going to stay the same every breath. It's going to change to target a delivered tidal volume. So one breath, the pressure support could be 5 centimeters of water. But if on exhalation, the patient is exhaling a small volume, the ventilator will deliver more pressure on the next breath. So the pressure will vary from one breath to the next until the exhaled tidal volume is equal to the set tidal volume. And it can go the opposite way too. So if pressure support of 15 centimeters of water is being used, and now the exhaled volume is too big, now the ventilator will decrease the amount of pressure.
Yvonne,
Yes.
how is that different from PRVC?
PRVC is waiting, or is you have a set rate. So if the patient goes to sleep and stops breathing, you have a set number of breaths.
So this
If
is
they wake up and assist,
this isn't a full support mode?
no, it's a spontaneous mode.
Okay.
Yeah, let me put that in here. Can't get there. So I wrote volume support is a spontaneous mode of ventilation. It's only spontaneous breaths with pressure support. There is no set rate. If apnea occurs, the ventilator will change to volume control and it continues to alarm. So if you have a patient come back from surgery, they're heavily sedated and you want the anesthesia to wear off, so they're on the ventilator waiting for anesthesia to wear off. So finally, it looks like they're waking up, you put them on volume support and they fall asleep again and they stop breathing. What's going to happen is they'll go into apnea ventilation. You're going to hear a constant alarm, and then you have to go and either switch them back over to full support until they wake up. Maybe Narcan needs to be delivered, but if they're on volume support, they need to be breathing spontaneously. Did I resume the recording? Okay. You are caring for a patient who is on servo-I ventilator in PRVC mode. You are asked to place the patient in the volume support mode. How do you determine the proper tidal volume you want to target? Like what is the targeted tidal volume you should set? Very good. IBW times spontaneous breaths are 5 to 7 mLs per kilogram. Mm-hmm. So 5 to 7 mLs per kilogram is a normal spontaneous tidal volume. So I gave you ranges in the past for patients with normal lungs going on the vent, like 6 to 8 mLs per kilo. If they're in ARDS, let's go down to 4 to 6. Very good. And then this is spontaneous breathing, 5 to 7 mLs per kilogram. How do you figure out how much pressure support is being generated to deliver the set volume? So imagine you've got your patient in volume support, you set up everything and begin ventilation, and now they're being ventilated in volume support. What are you supposed to look at to figure out how much pressure support is being used to get the tidal volume in? Any thoughts?
Do you look at the exhale tidal volume?
Yes, but the question is how much pressure support was used?
Wouldn't it depend breath by breath? So maybe
Okay, so one breath goes in, the volume's delivered, how much pressure support was used?
it would
You could do that. Yes, very good. I don't know if you guys heard, but it's peak pressure minus PEEP or delta P is going to be how much pressure support was used. Inspiratory pressure or pressure support? Yes. Yeah, so you want to keep track of that because if it's like 25, 30 centimeters of water for your pressure support, you think your patient's ready to be extubated? No, right? So you need to keep track of what the peak pressures are. That's going to give you an idea of how much pressure support is being used. So high pressures, no, their lungs are not ready for being extubated and breathing on their own. Okay, here it says with the servo I, volume support, you set a target tidal volume. The ventilator will select the amount of pressure support to achieve the target tidal volume. You need to set your flow cycle off or your inspiratory cycle off. You also need to set a high pressure limit. Why would that be? You're in a spontaneous mode and you have to set high pressure limit? Why? Salud.
Avoid barotrauma.
And then why would barotrauma occur? What could happen? Tiffany, I think you had it right. Yes, very good. So if the inspiratory pressure is allowed to vary to target a tidal volume, we need to set a limit as to how high that pressure can go. So in volume support, yes, we need to be careful and set a high pressure limit. Same thing with PRVC. Auto mode, I talked to you about auto mode during mechanical ventilation 1, right? Auto mode is just a switch between two different modes. So it says when auto mode is turned on, the ventilator switches from a full support mode to a spontaneous mode. Only if the patient triggers 1 or 2 spontaneous breaths. The ventilator remains in the spontaneous mode as long as the patient triggers breaths. If the patient stops triggering breaths in a short period of time, the ventilator will switch back to delivering mandatory breaths. And you, yes. You get an alarm with a backup rate, and here you don't get an alarm. That's actually a test question. I'm glad you asked that. So it says, you know, you got a patient, they're in auto mode. They're going between PRVC and pressure support, and they stop breathing. And they switch back to PRVC. Are you going to hear an alarm? No, you don't get any alarms as they're switching back and forth between full support and spontaneous. Okay, here's another scenario. You have a patient in CPAP pressure support. They fall asleep and stop breathing. The ventilator alarms, it goes into backup ventilation. Will you hear, does the alarm continue? I kind of gave the answer, didn't I? Will you hear an alarm? Yes. Will the alarm continue as long as they're in backup ventilation? The answer is yes. Yeah, that's a multiple choice question that usually everybody gets wrong. So I'm glad you asked. I like that. Yes. There's a way to look in trends, and you can see when they're just getting the mandatory breaths and when they're getting spontaneous breaths. So you would have to look in the trends in order to see how long they've been in one or the other. Is auto mode really a mode? It's a switch. So I said PRVC pressure support. I should have said PRVC volume support. I would have gotten that wrong on the test. So when the patient's in PRVC and you turn auto mode on, what's going to happen is if they wake up and start breathing, the ventilator will notice and it'll switch them over to volume support. They'll continue in volume support as long as they're breathing spontaneously. But if they fall asleep, they go back into PRVC. Question, Tijin? No. You don't get that choice. You're right. You need to talk to the ventilator manufacturer and say, hey, I want to be able to choose the two.
Volume support and PRVC probably go together because PRVC is volume targeted, right?
Yes. You're right. It wouldn't know how much pressure support. It only knows how to target a set tidal volume. Yeah, very good. It asks you what needs to be set on the ventilator. A high pressure alarm? Yeah. Okay, that's for the PRVC part. Now, what would you set for the volume support part? No, you just set your targeted tidal volume. And I guess yes, very good. And then there's also trigger timeout. What the heck is trigger timeout? It's how many seconds of apnea before it switches over to full support. Yeah, so trigger timeout is apnea time. Did I get too wordy there? I think I said more than I needed to. I like that. How many seconds of apnea before it switches back to PRVC? That's what you wrote? Okay, good job, guys. And then for pressure control and pressure support, what needs to be said on the ventilator? And rise time, yeah, pressure breath. Inspiratory cycle off, okay. Very good. And trigger timeout. Yeah. Pigeon? No, so you just go into, like the last one is volume control. And then you turn auto mode on. And then that allows you to set up your like volume control, volume support stuff. That's what I should add to this, right? Picture of the ventilator drop down. Yeah. Time to retire and now I've got it perfect, you know?
When it's just right. When you say goodbye, when it's right.
When it's just perfect, then say goodbye.
Absolutely.
I like that thought.
Not putting you for anything.
Oh. How can you tell which mode the patient is currently in? Yeah, you get the auto mode turned on or it's turned off. So how can you tell which mode the patient is currently in? If auto mode's lit up, patient is in spontaneous mode. And then, of course, you'll notice the color change when there's spontaneous breaths, you know, your flow changes. If you're breathing spontaneously, you are not breathing spontaneously. If you have a patient on the ventilator on the servo I and they're breathing spontaneously or they're assisting, how would you know by looking at the graphics? Very good. So on the flow waveform, you get like a pink, like instead of it being green, it changes to pink when they initiate a breath. Yeah. But the pink color change. Did you know, and I just found this out last year, that if you change over to pressure sensitivity, the color change shows up on the pressure scaler instead of on the flow scaler. Since we always put the machine in flow by, we always see it on the flow. So something. Ah, that's right too. A little T with a circle. How can you tell the amount of time that the patient has been breathing spontaneously or has been receiving full support? Yes, very good. Look in trends, and that shows you the breathing over the last hour or 24 hours. So that's how you would know. Yeah, it's I guess one of the pitfalls of using auto mode. So if you think your patient's doing great and they're ready to be extubated, it's possible that they've only been breathing spontaneously for a few minutes. You know, you walk in the room, oh, look, they're breathing spontaneously, they're awake, it's time to extubate. But what you don't know is they've only been breathing spontaneously a couple minutes. The rest of the time they were in full support mode. So that's one of the downfalls of being in auto mode.
This is very similar. Mixing SIMs, ACDC with SIMD. Isn't that one of the downfalls of using SIMD as well?
Yeah,
We see if they're getting better, because it keeps switching back to a full support mode.
well, with SIMV, it's like every few seconds, it's giving them, helping them with a breath.
With this one, it's 7.
Yeah. It's 7 to 12 seconds is the range for trigger timeout. Did you guys hear that? 7 to 12 seconds for trigger timeout. So auto mode is designed for patients waking up from anesthesia and sedation. It can also be used as a weaning mode. It is not recommended for patients who have a high work of breathing. The ventilator will not provide any support to the patient. And we've talked about this already. So with volume support, PRVC, the more the patient takes deep breaths, the more the pressure gets decreased, and pressure can decrease all the way down to 0, and the patient gets no help. All right, so if you wanted to go to auto mode using PRVC and volume support, you would click on PRVC and then you would click on auto mode. So you have a lab activity coming up with auto mode. We don't have class on Monday. So the Monday after. What is the difference between the servo I and the servo S? Does anybody know, Tidjin?
Does the S stand for sport?
What did he say?
Does the S stand for sport?
No, the S does not stand for sport. No, not spontaneous. So I have it listed. The servo S cannot be used with neonates. Did you guys hear that? I don't even know where to look anymore. I'm so used to looking at the computer podium, but the camera's actually up there. So the servo S cannot be used on neonates. The servo S, you can't use NAVA. And the servo S cannot be used in MRI. But can the servo I be used in MRI? No. So I don't know why it says that.
Is not being used on neonates? I think I remember seeing that.
Yes,
Okay.
yeah. Pigeon? No, not yet. It's coming up.
No, I just remember seeing it when we were at Joe D for one day, and I couldn't figure out, like, what is that? What does that mean? So, okay.
You guys have to know so much information. And you deserve to be paid well for the amount of information you have to know to do your job. Isn't it amazing? And so many people have no idea how full your curriculum is. Yes. Yeah, you put a feeding tube, it looks like a feeding tube. It goes down the esophagus, but it has little metal sensors on there and it can sense when the diaphragm contracts. So it knows when the baby's breathing in or the adult. It's another type of sensitivity setting, I guess. So instead of flow by sensitivity or pressure sensitivity, you can connect this cable to the ventilator. It sees when the diaphragm contracts and it knows when the patient's breathing in. So that's it in a nutshell. Yeah. And then to tell you that oh, so you can use it on pediatrics, not adults and pediatrics. It doesn't have auto mode. Whoever said that was correct. In 2021, they stopped manufacturing the Servo I and the Servo S's. So in the next few years, you'll see hospitals eventually getting rid of their Servo I's and moving over to the Servo U.
So they stopped making it.
Yeah. So once they stop making them, they'll stop making the parts for them shortly after. So they're letting the hospitals know, hey, this is coming to an end. Yeah, the Servo I has been around maybe 20 years,
That's
which is
mostly what
long
that
for
guy
technology.
was.
Yeah. Yeah, they started purchasing Servo U's also. Yeah. Yeah. I like the face that goes along with it.
It's too high tech. It's like it's just
Yeah, I agree.
LTV, that was great, but the Bella Vista.
Not so great.
Great.
Okay, and then the last slide, it talks about using an external flow meter to run a nebulizer when you want to deliver a bronchodilator. If you don't have the AeroNeb, then you have to use a standard nebulizer. You put it in line with the ventilator circuit. So why is that not a good idea? So first thing it says, when you do that, you increase the tidal volume to the patient. And you guys did this in your lab last year, where when you add that external flow, you actually make the tidal volume bigger by 120 mLs-ish. So that's not a problem for the adults if during the treatment they're getting an extra 100 mLs. But on children, infants, that's huge. So you would never do that in pediatrics. Another thing that you do is you change the FiO2 being delivered to the patient, because either you're bleeding in pure oxygen or you're bleeding in air, and that's going to change the FiO2 the patient's getting. The other thing is standard nebulizer nebulizes continuously. So it's nebulizing while the patient is exhaling. So all of that medication just goes out the exhalation port. Adding that extra flow negates the low volume alarm. Do you know what that means? Negates, cancels. You're not going to get a low volume alarm with a leak because you're adding all this extra flow. And the ventilator cannot sense the patient's inspiratory effort. So with flow by sensitivity, it's waiting for the flow, a little bit of flow to be missing, but you added so much flow, the ventilator doesn't see a little bit of flow missing when they breathe in. So those are all reasons why it's not good to add a nebulizer to the circuit and use an external flow meter. And that ends the show. It's 3 o'clock. So how about a break? we'll try to get you loaded in, and then we'll start on pulmonary function. So with pulmonary function, I'll close out this recording and I'll open pulmonary function and the PFT D2L. I didn't think it through well enough because I have some handouts that you do by hand to try to understand force spirometry, FEV1, FEV2, FEV3. So maybe I'll run downstairs, scan it, upload it so that I can at least show you a picture while you're on mine.